Hello. What we're going to be working on in today's video is how to take trig limits. And this is just the beginning of what we'll be doing for quite a while. So first off, let's take a look at what we have over here. Okay, and we should have this on our, on our little note card, that the limit as x approaches 0 of the sine of x is equal to the limit as x approaches 0 of x over sine of x, which is the same as the limit as x approaches 0 of the sine of some number times x over that same number times x, and they all approach 1. So we're going to need that. And I also have up here the double angle formula for sine, which is going to be important for a couple of problems. So let's take a look at my example. What I'm asking you to do is find the limit as x approaches 0 of x times the cotangent of x. So we have to remember our trig identities, that the cotangent of x equals cosine of x over sine of x. So what I've done in this first step, if I've simply replaced this, I've substituted in cosine x over sine x. And now if you look, we have as x approaches 0, x over the sine of x. Well, that reduces to 1. And we needed to do that because if we had put the sine of 0, we would have had 0 in our denominator. So we try to simplify whenever we can. At this point, we're just left with the limit as x approaches 0 of the cosine of x, and I'm going to drop that 0 in right there. The cosine of 0 is 1. So that was how we have to do that. We have to be able to simplify whenever possible. Okay, so let's work through a couple of problems together. Looking at number 1, we have the limit as x approaches 0 of x over the sine of 3x. Now you might think, oh, I can just cross out the x and the sine of x and I would be left with that 3 in the denominator. Not so fast. We have to think about the rule that says we have to have the coefficient in here and here to be the same. So what I'm going to do is I'm going to multiply by 3 over 3. And I'm going to multiply the 3 here, just so you can see what it looks like, and the 3 down here. Now, 3x over sine of 3x will reduce to 1. And our limit, as we're approaching 0, is 1/3. Okay, we need to see that work because we have to make sure it's in the right format to match our special rule. Number 2, the sine of 2x over 3x. And again, the limit has to be approaching 0. Remember, we would normally try to put the 0 in here, but we would have a 0 in our denominator. That's a problem. So if I have the sine of 2x, I would need to have it be over 2x in order to reduce that to 1. So I'm going to multiply by 2 over 2. What that does for us is the sine of 2x and the 2x reduced to 1, and we are left with 2/3. So that's the limit as x approaches 0 of sine of 2x over 3x. Okay, let's check out the next one. We have the limit as theta goes to 0, theta approaches 0, of 3 sine of theta over 2 theta. Well, this is just sine of theta. That will reduce with theta. And what are we left with? 3 over 2. Okay, number 4. We have the limit as a approaches 0 of sine of a over tangent of a. Again, if I put a 0 in here, I'm going to have a 0 in our denominator. The tangent of 0 is 0. So I'm going to replace that. And you have to think about, all right, what can I replace tangent with? Well, we're going to keep the sine of a, and I'm going to replace it with the sine of a over the cosine of a. That is an identity we're supposed to know. Now, we don't typically multiply or divide by a fraction. Instead, we multiply by the reciprocal. So I'm rewriting this. And what do you notice about sine of a over sine of a? They cancel out. What we're left with is the limit as a approaches 0 of the cosine of a, so in other words, the cosine of 0, which is 1. So So what we've done here is we're manipulating these values so that we can substitute 0 in. Okay, the next one. Oh, I have some reciprocal functions here. So the limit as a approaches 0, well, if I were to drop a 0 right here, we'd have a 0 in our denominator. And then we have secant of a over cosecant of a. I know the reciprocal of secant is cosine, and I know the reciprocal of cosecant is sine. So what I'm going to do is rewrite all of this. I'm going to keep this a in the denominator, but I'm going to take cosecant of a and rewrite it with the reciprocal sine of a, which goes to the numerator. And I'm going to rewrite secant of a with cosine of a in the denominator. Now, if I was to substitute 0 in, I would still have a 0 in my denominator. We know that's not okay. But look what we have. Sine of a over a as the limit of a as a approaches 0. Bye-bye. And so what we're left with is the limit as a approaches 0 of 1 over the cosine of a, which is 0. We just talked about this here. Cosine of 0 is 1. 1 over 1 is 1. Okay. And the next one, again, you might already know the answer. You might say, why can't we just cut to the chase? Well, if you want to get full credit, you're going to show me your work. So if we put the 0 in here, we would have a 0 in our denominator. We have the limit as a approaches 0 of the sine of 5a, so over a. So what we have to do is we have to make this a 5a in the denominator. Well, if I'm going to multiply the denominator by 5, I better multiply the numerator by 5. Sine of 5a over 5a reduces to 1, and we are simply left with 5. Okay, next page. Number 7. That looks interesting. It says the limit as x approaches 0 of the sine squared of x over x. I think for right now, it's a good idea to rewrite this as the limit as x approaches 0 of the sine of x times the sine of x over x. Okay, so this is how we write the sine of x squared. Okay, we don't write it like this, in case you didn't know. We don't write it like this. Oops. The 2 won't go in there. We write it like this instead. Well, when we do that, what do you notice? We're approaching 0. Sine of x over x reduces to 1. And now if we take the limit as the sine, when we put the 0 in there, what do we get? We get 0. Okay. Ooh, how about that next one? We have the sine of x over 5 over x, and we're taking the limit as x approaches 0. Well, if you think back to the previous problems, we had a coefficient here, right? Like a 5 in front of the a. So what you might want to think of this one, I'm going to do a little rewrite. The limit as x approaches 0 of the sine of 1/5 times a. Oh, it's an x, sorry. Make that an x. 1/5 of x over x. So if that's the case, we have to have the same coefficient in front of both of these. So I'm going to multiply the numerator and denominator by 1/5. Now I have 1/5 of x in the denominator, sine of 1/5 of x in the numerator. They cancel out, they reduce to 1, and the limit of this will approach 1/5. Number 9 and number 10, I'll work on those for you, and then I'm going to leave you to the rest of them. See what you can do. So the limit as x approaches 0, we always have to make sure we're approaching 0. If we were to substitute 0 in here, we would get a 0 in our denominator, but look what we have, sine of x over x. That reduces to 1 without any work. And now we'll take the limit as x approaches 0 of cosine of x. So cosine of 0, we've done this a few times by now. You should know it's 1. Okay, last one I'm going to do with you. If we put the 0 in here, direct substitution, we would wind up with a 0 in our denominator. I'm going to do a little rewrite. We'll have the limit as t approaches 0 of 15t over the sine of 2t over the cosine of 2t. But just like that previous problem, we're not going to divide by a fraction. Instead, we will multiply by the reciprocal. Okay, that's good news because it looks a little better for us. Now, if I want to, can I substitute in here? No, I'm still going to get 0 in our denominator. So what I'm going to do, I have the sine of 2t in my denominator. I'm going to multiply the whole thing by 2 over 2. What that allows me to do is reduce out the sine of 2t with 2t. What we are left with is the limit as t approaches 0 of 15 times the cosine of 2 times 0 over 2. Well, the cosine of 0 is 1 times 15 is 15, divided by 2 is 15 over 2. If you want, you can of course write that as 7.5 or 7.5. Okay? All right, you know what? I'm just going to do the last two problems with you. Okay, let's see what we can do here. So, these are a little tough. Look what we have. Okay, we have the limit as theta approaches 0 of the secant of 2 theta times tangent of 4 theta over 5 theta. If we put the 0 in here, we have a 0 in our denominator. We're going to probably have to change all this, don't you think? So let's rewrite the limit as theta approaches 0. Not going to do anything to 5 theta, so I'll just leave it there. Secant of 2 theta is 1 over the cosine of 2 theta. So here's my 1 over the cosine of 2 theta. Tangent of 4 theta is sine over cosine. So sine of 4 theta over cosine of 4 theta. Okay, what can I do here? Well, if I were to put the 0 here, I would still have a 0. But look what we have in our numerator. We have the sine of 4 theta. So if I can just multiply this by 4 in the numerator and denominator, what will happen is I can reduce sine of 4 theta and 4 theta to be 1. Cleaning this up, we have the limit as theta approaches 0 of 4 over the cosine of 2 times 0 times the cosine of 4 times 0. Well, we've done this so many times. The cosine of 0 is 0. So we have 4 over, the cosine of 0 is 1. So we have, oh, I'm so sorry, I forgot my 5. Always make a mistake. So we have 5 times 1 times 1. In our denominator, the limit will be 4 over 5. Okay, 4 over 5 times 1 times 1. Last one. Okay, here we go. We have the limit as x approaches 0 of x times sine of x over 1 minus cosine of x. Well, I put a 0 in here. I'm going to get 1 minus 1, which is 0. Can't do that. I have this 1 minus cosine of x. Perhaps you remember multiplying by the conjugate. So we're going to multiply the numerator and denominator by 1 plus the cosine of x. Okay, now that really is like a fancy 1, right? Because anything over itself is equal to 1. What does that do for us? It's going to change the look here. Okay, it's going to change how everything looks. So what we have in our numerator is x times the sine of x over 1 plus cosine x. I am not going to distribute or do anything. I'm going to leave it just like that. In the denominator, we get 1 by 1, which is 1. Outer and inner cancel each other out when we're multiplying by conjugates, minus cosine times cosine, which is cosine squared of x. You might think, well, what did that help? Because if I put a 0 in here, I get 1. 1 minus 1 is 0. But do you remember that 1 minus cosine squared of x is the sine squared of x. And that's our Pythagorean identity, right? And sine squared of x, I'm going to rewrite this. I'm going to rewrite, not changing the top, limit as x approaches 0, x times the sine of x, whoops, times 1 plus cosine of x. I'm going to rewrite it. I don't know why that came out like that. Sine of x times sine of x. You might be wondering, well, why did I write like that? Well, look what can happen. Sine of x and sine of x cancel each other out, reduces to 1. As we're approaching 0, x over the sine of x will also reduce out to 1. And what we're left with is an equivalent value where we have 1 plus the cosine of x. Now we can drop the 0 in there. Like the 5th time we're doing this, cosine of 0 is 1. 1 plus 1 is 2. Okay, so we are all done, people. Have a wonderful day.